Today's topic under the lecture series of Statistics and Management Studies is queuing theory. What is the significance of queuing theory in management studies is discussing now. What's a queue? A queue is a gathering of units in front of a server demanding for service. What is significance of queuing theory in management studies? So we analyze the factors of a queuing theory. Simply, only two factors. One is the units joining in front of a server for service. And the other one is the segments or sectors offering service. Simply, arrivals and servers. So what is the use of statistics here? We have two types of cost measures in queuing theory. One is the cost of units waiting for service. It is the waiting time cost. And the other is the cost of the server, service time cost. So it is a problem of management. It is related to cost. So what is the problem? Minimization of cost. But the problem here is different, since there are two costs and we have to minimize these two costs simultaneously. Therefore, at first we observe the relationship between the two types of costs: waiting time cost and service time cost. Time and cost. As you know, time is money. What is the relationship between these two costs? They are negatively correlated, or they are inversely correlated, or they are having indirect relationship. That is, if we try to minimize waiting time cost, the service cost will go up. Why? If to minimize the queue size, we have to provide more servers. That results in increase in service time cost. Otherwise, if we try to minimize service time cost, the waiting time of the customers waiting for service will go up. So this is the major problem in a queuing theory. There are two costs, and the primary objective is to minimize the service time cost and waiting time cost. Problem in queuing theory is to minimize both type of cost simultaneously. Here lies the application of statistics in queuing theory. That is, waiting time cost and service time cost are negatively correlated. Hence, a decision-making process is required. So what is the decision? Optimization of cost. Both type of costs are to be optimized. For that, we use the concepts of modeling. A queuing theory is to be modeled. Here also we have two types of variables: exogenous variables and endogenous variables. Endogenous variables means the variables included. That is only one variable here included, that is the number of servers. All other variables are outside the purview of the server. They constitute the number of arrivals, the amount of waiting time, the amount of waiting time cost. They constitute exogenous variables. Therefore, it is little bit challenging to an entrepreneur to formulate theories related to queuing theory to minimize both type of costs. And nowadays, it has wide significance, since the service is online, or the queue is different from physical queue. It is changed into virtual queue. Even then, the basic terminology, the basic structure of queuing theory has no change. So in queuing theory analysis, statistics is widely used. The one is the application of correlation. The other is application of some probability distribution. What about the number of arrivals? The number of arrivals cannot be controlled by the server. and the possibility of arrivals is very large, and the actual turnout in the queue is comparatively small. So it is called a probabilistic distribution. Probabilistic, it is termed as Poisson distribution. And the number of services or the service time is again a probabilistic distribution. It is exponential distribution. It is based on lack of memory property of a variable. Both these two distributions are used for analyzing a queuing theory problem. Now we are discussing the elements of a queue. It is also termed as characteristics of a queue or components of a queue. Mainly 3 components. Now I have added one more, 4 components. So what is a queue? The number of units waiting in front of a server for service, and the service pattern. How will you offer service? Then what is the queue discipline? And how will you expect the behavior of a consumer waiting for service in a queue? These 4 components constitute the elements of a system. For the studying of a queue, these 4 components are evaluated. 4th one is not an important component. The first 3 are. This has some mathematical aspect also. In any queue, the major and prime component is the number of units joining in front of a server for service. It is termed as the arrivals, the units waiting for service. Then how many units may join in front of a server to form a queue? From mathematical point, that is infinite. It is termed as the possibility. It is possibility of units joining. Possibility of units joining in front of a server for service. It is infinite. There may be infinite number of units. Infinite number of units may join in front of a server. That is a problem. Suppose an entrepreneur is ready for serve a customer. What about his service conditions? What about his arrangements? Suppose there are infinite customers. He has to arrange for infinite. So that is not possible. That is not the practice. So we introduce another term. What is the probability of joining a unit? The probability, what is the chance of unit? This probability is negligibly small. So we have 2 terms about the arrival pattern. The possibility for arriving or joining a queue is infinite, and the probability for number of units is negligibly small. That is making 2 terms. Possibility is qualitative and probability is quantitative. Possibility, it may be very large. Probability, it is negligibly small. Then again a problem is there. By which standards, which measure an entrepreneur make a counter, arrange a counter? He has to know the average number of customers, average number of arrivals that he can compute from the past experience. Therefore, this one more, what is the average arrival? Average arrival that is known from past, from the neighborhood or from the past. Therefore, the 3 terms constitute the characteristics of an arrival pattern in front of a queue. That is a particular term in statistics. It is termed as Poisson process. Poisson. That is the distribution of That is Poisson process or Poisson distribution. What is that? That's a distribution where the chances are infinite, but the actual number of occurrence is negligibly small. That is the first component of a queuing system. That is, the arrival pattern is, all other things are ignored. Only one term is used. The arrival pattern follows a Poisson process. Poisson process means the number of arrivals, average number of arrivals is known. Average number of arrivals is familiar to the entrepreneur from past experience. Poisson process is the pattern of arrival. The two terms, possibility is very large, probability is negligibly small. That is the Poisson process. That is the first component of a queuing system. The arrival pattern is Poisson process. And the number of arrivals is out of control of the entrepreneur. He has no control. He can only expect. So the term is average. The average number of arrivals, that is, he can expect from past experience. He has no control on the number of arrivals. Then what about the second term? That is service pattern. That is the number of services that can be offered by the server. Then we define this arrival pattern with respect to time interval. The number of arrivals within a time period. Then service pattern is the number of services that can be offered within the same time period. The number of services that can be offered within the same time period. That's again a statistical component. When a customer is waiting for service in the queue, he is so vigilant, he is so bothered, he is so active to receive the service. Once he derived the service, once he satisfied his service, then the waiting time for service is insignificant. The time waited for service is insignificant. So we have two times: the time spent in the queue for service and the time for service. Then after that, the customer will ignore. The customer becomes indifferent. The time waited for service. That is again a statistical term. That is exponential. That's a distribution. Exponential process or exponential distribution. Therefore, we have two terms. One is the arrival pattern is Poisson. For an entrepreneur, that is sufficient. Or for a student, what is arrival pattern? It's a Poisson process. What is service pattern? That is exponential process. Exponential process. That's a special property. That is a property known as lack of memory. Lack of memory. What is that? Once we get a service, the waiting time becomes insignificant. The consumer ignores the importance of time waited in the queue. It is known as lack of memory. So these two factors. Then third one is the queue discipline. How will you arrange? An entrepreneur or a server will arrange service for queue. How? There are several patterns. The most familiar pattern is known as FIFO, the mechanism of offering service. That is first in, first out. The customer who joining the queue, at first will receive the service. That is a pattern for service. That is queue discipline. It is known as FIFO. Our experience is that the usual queuing theory follows this theory. The customer coming at first will get the first service. Second one will get second service. That is FIFO. First in, first out. And second one is, it's complementary. Last in, first out. The unit entering the last unit getting the first service. That is, you are familiar in the go down or in a bookshop, the books are arranged, and the last one put will take at the first, that is first in, last in, first out. Third one is first in, last out. That is the complementary of this. And fourth one is priority queue or random service, random service, that is taking a lottery method, or from a collection of units waiting for service, one person is taken at random. That method is used when all the elements waiting for service are having equal weightage, equal importance. And the last one is service in priority, that is VIP queue or priority queue, priority service. That is, if all the units are not equal, important person, very important person, very important persons, there is a pattern of service offering with respect to the characteristic or priority of the units waiting in the system. These are the major components: first in, first out, last in, first out, random service, priority. This is only a technical importance, first in, last out, only technical importance. That's complementary, last in, first out, etc. So these are the FIFO, LIFO, PHILO, random and priority queue. Then next we are going to explain the behavior of consumer. Then the behavior of consumers. Consumers means, in this context, consumer is the unit waiting for service in front of a server. Then there are mainly 4 types of customer behavior, the units behaving. The first one is bulking. Customer behavior, the first pattern is bulking. Suppose a customer is coming for service in front of a queue. Without joining the queue, the customer will leave the space. Why? There is no space for waiting. There is no space for waiting, and he has no time for wait. If the queue is very large, lengthy, there is no space for waiting, there is no space for parking his vehicle. In such cases, the consumer or the unit will leave the queue. It is called bulking, the consumer behavior. Second one is reneging. There is another behavior. That is, a consumer leaves the queue because of his impatience. He is not ready to wait for service. So waiting for some time, then he will leave. It is called reneging. And the third one is, that's a procedure of jockeying. If there are several servers for the same service, the consumer will jump from one queue to another. Wait for service at one queue for some time, then jump to another queue, then jump to another queue. That is jockeying, bulking, reneging, jockeying. This is a usual 3 consumer behavior. And the other one is collecting a bulk of service for a group of consumers. One person collect the entire service. It is known as collusion. So these 4 constitute the consumer behavior: bulking, reneging, jockeying and collusion. Bulking, leaving the queue since there is no space, no time to wait. Reneging, leaving the queue with impatience. Jockeying, jumping from one to other. And collusion, collecting a bulk of service. For the analysis of a queue, we have to identify the components of a queue. It has 2 segments. One is explained as A, B, C, and the second segment is identified as D, E. This is a model for analysis. In statistical analysis, we use always some models. This is a model. What are the components of this model? The terms discussed just now, that is A is the arrival pattern. Arrival pattern, that is we are familiar, that is Poisson process. B is the service pattern, that is exponential. And C, that is the part of the entrepreneur, number of server, number of counters, number of servers. How many servicing units are there? This constitutes the first set of a queuing theory analysis. 3 components: arrival pattern, Poisson process; B, service pattern, exponential process; and the number of servers. This is determined by the entrepreneur, by the server. And these 2 factors, 2 more factors are there. One is D. D is the space allowable, the space provided for servers for waiting. That is the permitted queue length. How many units are permitted? In some cases it is restricted, only 10, only 15, only 30. There is permitted queue length. For a cinema hall, the number of seats are permitted, restricted. There is permitted queue length. And E is the service mechanism. How the entrepreneur offering service. We know that first in, first out, first in, last out, last in, first out, priority queue, Cicero, etc. That these 5 components constitute a components of queue used for analysis. There is no illustrations in terms of numerical values, that is no problems in this lecture series. Here I am providing some theoretical explanation. Now I am breaking this class into 2, stopping here. In the next class, the remaining part of the queuing theory, the model analysis, etc. will continue.